Hello guys, welcome to Friends in Tech Automation. We provide practical PLC, SCADA and IoT training. So in our today's video, we are still continuing with our series in panel HMIs, how to design panel HMIs in TIA Portal. These are what we call SIMATIC HMIs. In today's video, we want to do alarm configuration. We want to learn how to add alarms because alarms are very important. They tell operators when there's a problem in the system, when a component fails in the system. So it notifies operator. I mean, you cannot do operation without alarms. So what we have here is HMI underscore 1, and this is KTP 700 basic PN. You can add any other HMI depending on your hardware HMI. So you have to match the two. Now, if you check our previous video, we did tag linking, that is linking your HMI tags and your PLC tags. Because remember, one thing is that you have to integrate the two. PLC and HMI must be integrated. So you have to link PLC tags and HMI tags. Then another thing, today I have added another CPU here, another PLC. So you see I have PLC2 here, which is CPU 414-3. The reason for adding this is because my factory IO libraries are misbehaving with step 7-1200, but they are working perfect with step 7-400. So I'll be using this step 7-400 to get real-time data about level monitoring for the tanks this year. So we have, this is tank 1, tank 2, tank 3. According to our HMI, we call them fuel tanks. So this is first HA4 tank 1, HA4 tank 2, and HA4 tank 3 here. So I'll be getting some real-time level readings from factory IO. Then I want to use those, and based on my set point, I'll be generating some alarms. So the first thing we'll do here, we'll add alarm conditions. We have to know alarm conditions. For example, we want to say that when level is below 20%, we want to say low level alarm, or we need to have a low level alarm. Then we want to say also that when level is above 90%, then we want to raise an alarm, high level alarm. So you have to write a logic for those alarm conditions. Now, the first thing, I've added this PLC underscore 2 CPU 414. This is not a problem because remember your PLC project can have more than one PLC. And the good thing with HMI can access all those PLCs. All right. Now, if you come to devices and networks here, let's see how I've linked these two PLCs to one HMI KTP 700. So this is CPU 1211C, that is step 7-1200, and this is step 7-400, CPU 414-3 PN/DP, supporting both Profinet and Profibus, and they are linked here using Ethernet, then to the HMI, this here, KTP 700 basic. So it's the same thing. So what I've done here in PLC underscore 2, I've only added this block here for scaling of the levels that I will be getting from this factory IO, the readings that I will be getting from factory IO here. I want to scale them into a range of 0 to 100%. So if you double click on analog scaling here, it is nothing. I've just added scaling, the same thing we did in step 7-1200. So you realize this is just scaling, and with step 7-400 we don't do much here. Scaling is really simple. You just have to specify you want to scale to what range. So we want to scale this to 0 to 100. Input will come from this factory IO. So we have just used a placeholder here, or a temporary variable hashtag sensor this here. And we want to scale this between 0 to 100, and whatever we are getting out of this scale block, we are calling it scaled underscore level. Then I've called this, remember this is a function block. So I have tank 1, tank 2, tank 3. So I've called them here. So if I go to main program here, I've called this block, this scale block, or analog scaling FB 3 times. So if I scroll up here, you see that now I have level 1. This is for level 1, that is for HA4 tank 1. This is for level 2, HA4 tank 2, and this is HA4 tank 3. And you realize that I've not defined these things as memories because I've created a DB here, a global DB, HMI underscore DB. And I've defined this level 1, level 2 in this HMI, DB. Now, at least now you have that. So the next thing we need to do here, we need to create alarm conditions. So I'll add a new block here. So just double click on this here. And you can add a new block. So you can decide to use FC or FB block. So for that matter, let's just use FB here. And let's call this alarm conditions. Alarm underscore conditions. And that's it. So you can add this, click OK. So you have a data block. I mean, we have a FB block here for alarm conditions. Like for example, we want to say that when level is below 20%, we want to do something. So in order to do that, you have to use comparators or data handling techniques. And one of data handling techniques you can check in our previous video is comparing data. So you get to compare two data, then you can make a decision. Now, here I want to create an alarm condition that when level is below 20%, I want to raise a low level alarm. But something also, I want these set points to be dynamic. I don't know if you're getting that. So the thing, let me just demonstrate this first. So I'll go to basic instructions, then come to comparator operations here, then select this one. You can use less than, compare this here, drag it here. So look at this. Look at this. So here you want to compare set point and level. You want to compare set point and level. And remember, the level that you want to compare is scaled level. This here. You want to compare this here. This output. If it is for tank 1, you want to compare with this scaled level HMI underscore DB dot level 1. So go back here. Alarm conditions. So here we can put HMI DB level 1. So if this here, you can see it's real. If this here is less than, if it is less than 20.0, that is 20%, then we want to raise an alarm. Just simple. We want to raise a low level alarm. So we want to raise an alarm here, and we can add an output, a placeholder for that. And we can call it alarm. And that's it. So this is an output. So, and we can put it here. Or maybe you want to put low level, sorry. Let's call this level low. Level low. That's it. So you can refer it here. Level low. And that's it. Now you have this here. Level low. So you can do the same also. You can compare as well. Let's say you want to compare this here. If now level is greater than, so you want to add this here. And you want to compare HMI, the same tag, because for one tank we must have level high and level low alarms. So this is level 1 still. But now this here, if this level is greater than, let's say 90.0, so if it's greater than 90, then we want to raise, we need to raise, so I'll add another one here. Oh, sorry. So here we need to have level high. So level underscore high, and that's it. So we can define it here, level underscore high, and that's it. So we have those two there. So this is for, we can say this is for alarm conditions. Alarm conditions for tank 1. For tank 1, that's it. So you have to do the same for tank 2 and tank 3. So I'll just copy this here. Just copy everything here and come paste it here and paste it down here. And that's it. So you have to change this here for tank 2. So you have to change this network here. This is alarm conditions. Alarm conditions. Conditions for tank 2. And that's it. So you have to change this here to level 2. You have to change this also, level 2. And I have to define low level for tank 1, tank 2. So I have to modify this here. I have to modify this here, level low for tank 2. Also I have to define another one, level high, level high for tank 2. I have to define another one, level low. So you realize that there's some, I don't know, what can you say here? So we need to add this, change this here to low level 3. That's it. And now we have high level 3, level high 3, level high 3. That's it. Now if you go up here, I have to modify this. Let's just say 1, and this is also 1. That's also 1. That's it. Now down here I need to add something else. Let me just add level low and level high underscore level high, and that's it. So that's what we have there. So the first network 1, that is alarm conditions for tank 1. This is alarm conditions for tank 2. So I have to change this here to 2. That's it. So I have to change this one as well to 2, and that's it. Then for tank 3, this is alarm conditions. Alarm conditions for tank 3. That's it. So you have to change this also. Double click on that. Change this here to 3. That's it. Then also change this one here. Change this to 3, and that's it. So you have created your alarm conditions for tank 1, tank 2, and tank 3. Then I want to create a general low level and high level alarm. General in the sense that when any of the tank level is low, I want to raise an alarm low level. So what I'll do, I'll add normally open here. Then I'll add another branch. Then normally open. Then just close this here. Then add another branch here. Normally open, and that's it. Then add an output here, and let's say this is low level alarm. Okay, so this is just low level or level low. You can call it level low. That's it. So here we have to call this here level low 1, level low 2, because this is for low level. So this is level low 1, level low 1. Then here you have level low 2, level low 2. That's it. Then you have level low 3, level low 3. That's it. Now that's good. That's network number 4 for general. Then I have to add network number 5 for also general for level high. So I normally open there. Then add a branch. Then add normally open. Add a close this branch here. Then add another branch down here. Add normally open. And just close this here. And that's it. Then add an output. That's it. And this here is level. Let's call this level high. Okay, high 1. So this is level high 1. Okay, and this here is level high 2. Then this here is level high 3. A level high 3, and this here is just level high. This here is just level high. And that's it. So you are done with your alarm conditions level high. So remember, anytime you create a function block, it can be FC or FB, you have to invoke them, or you have to call them in your main block. All right, you just have to call them in your main block. So go back to your main block here, that is OB. Then call this alarm conditions. So I'll call it down here. Just drag and drop it here, and that's enough. So let's just say okay. So I have it here. So we have to define this low level 1, low level 2, low level 3. So what I will do, I'll create alarm tag. So I'll go to PLC tags here, PLC tags here. Then I will create a new tag table, and let's just rename it to alarms. So let's rename this to alarms. This is something we have done also. Let's just rename this to alarms. That's it. And now we can open this, double click on that to open. So we can add those tags here. For example, I want to add low level or level low. So level low, so let's just do this here. Let's say tank 1 underscore level low. That's it. So I'll then add also tank 2. And remember, these are not, let's not misuse our inputs here. Instead, we'll change this to memory. Let's just change this to memory. Instead of misusing them here, let's change this to memory, and I will start at maybe 2. I guess I've used 0.0. That's it. Then here, let's add tank 1 underscore level high. That's it. So you need to add also for tank 2 level low, tank 2 level high, tank 2 level, tank 3. So let me just do that, then I'll be back. And I will have all our alarm tags here for level 1, tank 1, tank 2, and tank 3. Then we have level low and level high. And I will create something here that I'll explain its needs. Alarm underscore trigger. And this here, I want to give it a memory address. I want to change this in fact first. Data type, I want to use this as an integer. Keep in mind that an integer is a 16-bit. Alright? The size of an integer is a 16-bit. That's very useful here. Then I want to change this here to address MW, and I want to start from 12 or maybe 20. Let's say 20, and that's okay. So I'll explain the need of this here. But first thing, know that integer, it's a 16-bit data type, okay? It's a 16-bit data type. It is a 16-bit data type. So 0, 1, 2, 3 up to 15. So that's it. Then let's just go back to our main program where we have invoked this. So here level 1, we can just add tank 1, tank 1 level low, tank 1 level high. So I will add these tags here, then I will be back. Great. Now we have all our alarms here, and this is good. So these are alarm conditions. So you realize that when this block is executed and all conditions are met, alarm conditions here. When these conditions are true, then we'll have alarms here. This here will be activated, and the point is that I want this here, I want to show these conditions in my alarm status table in my HMI. That is the goal. So after having defined these alarm conditions on your program, you need to add them, or need to configure them on your HMI. Alright, you need to configure this on your HMI. So the next thing, I'll scroll down to HMI here, expand on this here, then I'll go to HMI tags, this here. Then I need to create, I will create a new HMI tag table, and let's call it alarms. So let's add a new tag table here, and let's call it alarms. So I'll just rename this here. Let's rename it alarms, and that's it. Now let's double click on this here, this HMI tag table, alarms. Now we have it here. So I want you to pay attention here. This is the most important part. So I have this here. So add new alarms tags here. And I just add, you remember we created a tag called alarm trigger here, this here in alarms. So I'll just rename this to alarm trigger. Alarm underscore trigger. And that's it. So the thing is that when we say that when you want your HMI tags to have effect, you have to link them. You have to create some sort of connection between your HMI and your PLC. So you realize that here we have a PLC tag. So you have to select this here. But first, I have to check connections here. And I'll use HMI connection 1, and that's it. Now here, PLC, enter PLC tag. This is very important. But the problem is that it's giving me PLC 1 and these tags are in PLC 2. So first thing I need to do here, I have to come to device and networks. So other than just linking this here, we come to connections here, HMI connections. We need this here. So this is HMI connection 1. This is also HMI connection 1. Okay. Then let's try to change this here. Okay. Then we have to change this here by giving it the address of PLC2. So double click on this here. Double click on this. So I have to navigate to my PLC tag table. So I'll scroll down, not step 7 1200, but I want to use step 7 400. Then I will go to alarm tag, tag table or PLC tags here. Then I scroll down, I want to go to alarm, expand on this, then I want to go to alarms, and that's it. So under alarm, if you scroll down here, we have alarm trigger. I think it's the last thing here, alarm trigger, and just select this. And now that's it. So you can see that PLC name is PLC2 and PLC tag is alarm trigger. So remember, we created a tag called alarm trigger, a data type was integer, and address was MW20. Let me explain why we are using an integer here. So we have created alarms in this tag here. So in my PLC program, we have PLC tags. So I have these alarms, like for example, tank 1 level low, tank 1 level high, and also tank 3 level high and level low. Then I have just level low, level high. So if you look at this here, this is first bit. M0.2 is just first bit, second bit, third bit, fourth bit, fifth bit, sixth bit, seventh bit, and eighth bit. And if you use an integer here, an integer is a 16. It's a 16-bit data type. So if it is MW20, then I can confidently say that M20.0, I can assign it level low, tank 1 level low. M20.1, I can assign it tank 1 level high. So the point is that this alarm trigger integer will host my alarms, because I want to create discrete. I want to create discrete alarms here. Like for example, now here, I need to create discrete alarms. So if I double click on this here, add new here, so you can see alarm ID is 1. Then alarm trigger tag here. So I have to specify this here, so you can see this is M20. M20.1. M20.1, 21.0. Look at this. This is M21.0. Just a minute. Okay, good. So we have this here. 1. Look at, I want you to focus with this trigger address, M20.0, M20.1. If you go back here, we can say instead of giving it discrete alarm 1, then alarm text here, we can say this here. This here is tank 1 underscore underscore level low. There's something I will edit back there. Level low. And that's it. Then go to tank. This one here, name it tank 1. Tank 1 underscore level high. So this is how you do alarm configuration. Then if you add another one here, ID3, look at the bit. Look at this. This is very important. 21.2. This here. So 21.0, 21.1, 21.2. And here we have tank 2. This will be tank 2 underscore level low. Add another one here. So we have 3, 4, 5, Okay, I think that's enough. This here will be tank. This here will be tank 2. Tank 2 underscore level high here. Then this here down here will have tank 3 level low. Tank 3 level low. Then here also you have tank 3 level high. Level underscore high. And that's it. Now, importantly here we need to add another one, 7 and 8. So this here will have just level low underscore level low, and this here will have let's rename this text to level high. Now this is very important here, so I want you to write down somewhere these addresses here. So we are starting at 21.0 M21.0 all the way to M21.7. Now you have to ask yourself here, what is the relationship between this M21.0 and this alarms here? If you go back to your PLC tag table, this here. So you realize that there's no relationship between M0.2 and M21.0. So you have to edit these addresses. So instead of M0.2, you have to change this one here to 21. Yeah, oh, sorry. 21. Oops, 21.0. This here is 21.1. This here is 21.2. 21.2. You have to change all this. This here is 21.3. 21.3. This here is 21.4. This is 21.4. Then this here is 21.5. This here is 21.6. 21.6. Then finally this one here is 21.7, and you're done. So that's it. So save your project here, save your project, but then there's one thing that we have to confirm, but this one will confirm by doing it by doing simulation. This here, you see trigger bit, this is trigger bit. One thing we say that this integer here, it's a 16-bit. all right, it's a 16-bit. So if you start, we have 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. So in our head we are assuming that when 0 bit will be triggered, then low level or tank 1 low level alarm will be activated. That is what we are thinking, okay? But somehow, sometimes you'll find that the triggering address will start maybe at 8 or maybe at 9. So you start at 8, 9, 10, 11, 12, 13, 14, 15. So it's not always 0, 1, 2, 3. So this is something you have to check. So I think we are done configuring alarms here. So the next thing, we have to add alarm page. So you go to our HMI, then screens here, come to screens, then we need to add alarm screen. So we have it here, alarm underscore screen. Double click on this here to open it. So adding alarms in SIMATIC HMI is not that straightforward. It is something you really need to understand. If you are using ignition, then it wouldn't be a problem because ignition is really quick. You can add alarms very fast. But with SIMATIC HMIs here, you have to really understand what you're doing. So this is the alarm screen. So you can just add some basic design here. So I come to basic objects. I think there's nothing much to do here. Just drag this here. I think that's it. That's it. Then you can come to properties. Then you can change background. And let's just make it black. So change background color. Let's just make it black, solid black. That's it. I think that's enough. Solid black, that's it. And then we can add a label here or a text. I just place it here. And we can call it alarms. And that's it. Then you can change properties here. And we just want to change the font color. So foreground color, let's just use white. And that's it. So that's it. Then we can just place it up here. That's okay. So you can ensure that it is centered. Okay, I can try to minimize this, or we can just do this here. So what next? So the next thing, we need to add alarm status table. We need to add alarm status table here. Good, perfect. So go minimize basic objects, then come to controls. Then you see here, this is trend view. Then we have alarm view, so or alarm status table. So drag this and drop it here. So this is your alarm status table. This here. I mean, you can try to do your design, change some stuff here, change colors. But anyway, we are just interested with configuring this here. And that's it. You don't really need to do anything here. Okay, you don't really need to do anything here. Just save your project. And that's it. Now let's try to run this program and see if our alarm will be triggered if we change levels. So you come to alarms here. So let's come to our main program. Sorry. And I will download this here to my PLC. Okay, the first thing, just a minute. Load. Okay. Now while that is not behaving, let's just stop CPU first here. Then load this program again. Let me just check that error, then I'll be back. Okay, there was a miss with this program here, so I've changed it. Remember, we included more than two outputs, two paths here, two output paths in network number one. So I've just separated this here. So I've just separated them into different networks, network one and network two. Also for this tank two, you have this as its own. Then we have another one here as its own as well. So let's just download this one now. Hit download. Change download selection here to consistent download. It will clear all those warnings, and that's it. The next stuff, we can start our CPU here, can run our CPU. That's it. Then next thing we can do here, you can go back to main program and we can do monitoring. So I'll just go online by clicking that guy. So I want to see if any alarm will be generated, but this year I will just play with factory IO. So look at that. So already you can see that level low alarm is true. So level low alarm is true. So of course level, if you are starting, then you'll know that level will be low. So if I go to alarms here, this one here instead, then I have to monitor this alarm table. Look at this. So you see M21 is true. This is interesting. This is what I wanted actually. Now look at alarm trigger. Alarm trigger current value is 85. Current value is 85. Can you tell me the bit that is triggered? So right now we have two that are, we have this one is true. M21.0 is true. Then M21.2 is also true. Then M21.4 is also true. It's also true. Then M21.6 is also true. But look at this here. In our definition of alarms here, in our definitions here, we say that, look at this here. We say that M21.0 it's bit 0, the first bit 0. So that's a 1. Then M21.1 is not triggered, so that's a 0. Then M21.2 is triggered, so that's a 1 there. Then M21.5 is not triggered, that's 0. Then finally M21.6 is triggered, that's a 1. So that is 101, 10101. So if you translate this is not from binary to decimal, it's not coming closer to 85. So it means that triggering has not started at bit 0, maybe at something else. So what I will do, I will just do conversion, then I'll check. Alright, so let me just explain this part very clear. This here, is this really 85? And if it is 85, what are the bits that are used here? So we can do our conversion here. So we have this here. Let me just do this here, because understanding this is really critical. So we start with this here. We have 1010101. So we have 1010101. So I believe those are 7 bits. 1 2 3 4 5 6 7 8 bits. So that is 8 bits. So if we do our calculations here, let's convert this binary to decimal if it is true. So we say that this is bit 0, this is bit 1, this is bit 2, this here is bit 3, bit 4, bit 5, bit 6, and finally bit 7. So let's just check if it is 85 indeed. So the first thing, this is 2 raised to power 1, this is 2 raised to power 0, plus, we ignore this one, this is 2 raised to power 2, plus, we ignore this one is 2 raised to power 4, plus, we ignore this one here, 2 raised to power 6. So you have to do addition here. So 2 raised to power 0 is 1. Let me just use another color. So 2 raised to power 0 is 1, plus 2 raised to power 2 is 4, plus 2 raised to power 4 is 16, plus 2 raised to power 6 is 64. So if you add 64 plus 16, that's already 70. I mean, that's 80. 80 plus 5, that is 85. So indeed, the bits that are triggered is bit 0, bit 2, bit 4, bit 6, and bit 7. Now, if we check in our alarm tags, tag table, this other one here for HMI, look at it. So the bits that are triggered are bit 0, and bit 0 is tank 1 level low, bit 2, I mean the third bit there, which is this one here, or bit 2. This is tank 2 level low. Then bit 5, which is this one here, is tank 3 level low. So that means that we expect in alarm status table, we expect 3 alarms: tank 1 level low, tank 2 level low, tank 3 level low, and even this one here. Then just level low. Now, what we'll do, we go to alarm screens here. Then I want you to hit on simulation. Just start simulation to run WinCC runtime. So I just hit on this here. Then I have it down here. Now you see my alarm screen. So look at it. So you can see 4 alarms are active. Pending alarms are 4. So we have this one here. It happened at this time. Date is today. And text is level low. Tank 3 level low. Tank 2 level low, tank 1 level low. And the thing is that if we start our simulation here in factory IO, we hit this here, I believe those alarms will be cleared. Let's just check now. I want you to monitor this. Once level is above 20, these alarms will be cleared automatically. Once level is above 20, you just have to wait here. Yeah, now level is above 20. Check if it will clear this. First thing, ensure that your drivers is connected. Okay, that's good. So look at this. Active alarms is 0. Active alarms is 0. So we just have these that are not acknowledged. So you can acknowledge them like that. So we don't have any alarm right now. We don't have any alarm. But once this level is above 90, it will raise high level alarm for all the 3 tanks. For all the 3 tanks. Let's just wait and see here. Now it's at 50. So this is how you do alarm configuration in TIA Portal. $60. it's quite slow. Let me just do this here. Okay, good. This just at 0. Okay. So look at this here. Look at this, look at this, look at this. It is 78, 78, 78, 80. So just 10%, just 10% away. Almost, and you see active alarms. Oof. 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 There. You can see all alarms, pending alarms. You see level high, tank 3 level high, tank 2 level high, tank 1 level high. And we have managed to add alarms to our SIMATIC HMI screen, panel HMI, KTP 700 basic. So once these alarms are cleared, you have to acknowledge